All right, guys. So more quadratic word problems. These are going to be EOC like some of the released ones we've done. So if the side of a square is increased by 5, the area is multiplied by 4. So as soon as you see the word square, I would draw a square. We know that a square, all 4 sides are the same. We don't know the side length, so we'll just call it x. The area of this square is x times x. So remember, area is side squared if you're thinking about just a square. But if we need one that applies to many, rectangle and square, it's length times width. So that would be x times x, which gives us the x squared for the area of our square because it's speaking to the area. Now, it also says that the sides are increased by 5. So I'm going to add 5, add 5. The area is multiplied by 4. So multiply the area by 4. Find the side of the original square. So again, area is length times width. So our area is 4x squared. Our length is x plus 5, and our width is x plus 5, or side squared, which would be x plus 5 to the second power. So we're going to multiply those together. You can do it by box method, FOIL, however you want to multiply these two. So x times x is x squared, 5 times x is 5x, x times 5 is 5x, and 5 times 5 is 25. X squared, clean up, plus 10x plus 25 equals 4x squared. Anytime you see an x squared, you want to get it set equal to 0. You would prefer your x squared term to be in the front in standard form to be positive. So I'm going to move everything this way. So I'm going to subtract x squared, I'm going to subtract 10x, and I'm going to subtract 25 from both sides, which will make both of these go away. I will combine my terms of those x squared, so negative x squared and 4x squared, which is going to give me 3x squared minus 10x minus 25 equals 0. Now, because we're still practicing, we're going to practice factoring. So a is not 1, so we know there's going to be a 3x and a 3x in here. A times c, so negative 25 times 3 is what goes in the top. So it's going to be negative 75. B goes in the bottom, negative 10. And I'm looking for the numbers that I multiply together to get 75 that will add or subtract to get me 10. It's going to be a 15 and a 5. B is negative, so the larger of the two is going to be negative. Now you're going to look at this not fractions. Remember, these are not fractions. We're just going to pretend like they are and see if I can reduce. So 3 and 15. That is reducible because 3 goes into 3 once and 3 goes into 15 5 times. So it's going to become 1x, and that's going to become a negative 5. 3 and 5 cannot be reduced. So our factors are x minus 5 and 3x plus 5. So those are our factors. So this is factored form. This is not solved. These are our factors. And to solve is what they're asking us to do because we want to know what is the value of x. And what is the value of x is the solutions, the x-intercepts, the roots, and the zeros. I can't say that enough. So now we're going to take x minus 5, set it equal to 0, and 3x plus 5 equals 0. I'm going to move that 5 over by adding. So x equals 5. I'll move this 5. I want to subtract because I need to do the opposite. So it's going to be 3x equals negative 5. Divide by 3, and we'll just leave it as negative 5 over 3. Talking about side length of a square, we have a negative 5 over 3 and then a positive 5. Hopefully, we already know that we can't have a negative side length. So the side length of my square is going to be 5. Now, if you can get to this point, we are more than likely to be calculator active at this point. So if you go to your calculator in Desmos and we plug that in, that 4x squared equals x plus 5 or x plus 5, and go see where it crosses the x-axis, it does cross at a positive 5 like we got when we solved the x minus 5 factor, and then a negative 1.6 repeating, which is the same thing as negative 5 over 3. And if you don't believe me, there's the negative 5 over 3 that we got from solving our factor, and here's our answer, which is also the same as this number here. They just rounded in, and then again, the 5, 0. So anywhere along the way, you can check yourself. If your answers do not come up, you can even put this one in. It could have been after that you messed up. So it could be the next portion if you're working it all the way out. So if you did 4x squared equals, and we got to the x squared plus 10x plus 25 portion, if we had distributed and multiplied this x plus 5 times x plus 5 correct, this should graph directly on top. So the red and the purple should be on top of each other as it is here. So you can check along the way as you go to make sure your math is correct as well. All right, so our answer is 5 for this one. Number 2, a rectangular lot is 20 yards longer than it is wide. So I'm going to have a rectangle. Again, length and width. It's based off of its width. It's just 20 yards longer. So I'm going to put plus 20. So our length is going to be width plus 20 because that's the length. And its area is 2,400. And remember, area is length times width. So we put that in times that. And the area is going to be 2,400 square yards. Find the dimension of the lot. So if our area is 2,400, our length is W plus 20, and our width is W. We can go from here straight to Desmos, but we're going to practice first. Let's distribute that W, so that's going to be W squared, 20W plus 20W equals 2,400. Again, as soon as you see that W squared, you know you want this problem to be set equal to 0. So I'm going to move that 2,400 by subtracting 2,400 from both sides to move it to this side. Those are not like terms, so it's 0 equals W squared plus 20W minus 2,400. And now you would need to factor. Those numbers are pretty large. So I'm going to assume this is definitely calculator active. It says find the dimensions of the lot. So we need to know the width and the length. So here, if I can solve for W, if I go to my Desmos, and I'd erase what I had before, and I go in this one and I put W squared plus 20W, and I'm sorry, you want to use X. I won't let you use different variables. I apologize. X squared plus 20X minus 2,400. We have a big quadratic somewhere. There we go. So it crosses at negative 60 and it crosses at positive 40. If we're looking for length, again, you're not likely to use a negative. So it's probably going to be our 40. So if we come back to our page here, 40 times 60 does give me that 2,400. So let's just pretend like we needed to look for the factored form. So it would be negative 2,400 on the top because this A is 1 times that with 20. We had 60 and 40. That 20 is positive, so the smaller the two factors is going to be negative. So my factors is W plus 60, W minus 40. If I set both of those equal to 0 and solve, that's going to give me W equals negative 60 like we saw in the graph, and W equals a positive 40 like we saw in the graph where it crosses the x-axis. So our width is 40, and that's for the dimension, so we know that the width is 40. And then the length is our width plus 20, so 40 plus 20. So our length is 60. So it's a 40 by 60 rectangle when we're done with that guy. 40 by 60 rectangle when we're done. All right, number 3, the length of a room. All right, let's just draw a room already. Is 8 foot greater than its width. So length, width, it's all relative. And the length is 8 foot greater than, which means we're going to add. So width plus 8. If each dimension is increased by 2, so we're going to add 2 to the top and add 2 to the width, the area will increase by 60 feet. Now, we got to figure out what the area was before we started making our changes, which is W times W plus 8, because it's length times width to get the area, right? So it's W squared plus 8W, so that's W squared plus 8W for our original rectangle. But now that we've added 2, then we are going to increase by 60. So we're going to add 60 to the area, the original area of the original shape. Now from this, we have to find the dimensions of the rooms. It says rooms, so we're going to do both. But we're going to use what we have here. So this, if we clean it up, is W plus 10. So W plus 10 times W plus 2 is going to equal W squared plus 8W plus 60. Now, if you could probably write it this way and then just add 60 at the end. So W times W plus 8 plus 60 here. And then we could use our calculator again without having to do much work. But we're going to work it out this way first, just for practice. So W times W is W squared. W times 2 is 2W. W times 10 is 10W. And 10 times 2 is 20. So this side is W squared plus 12W plus 20, which is equal to W squared plus 8W plus 60. Again, move towards whichever side you want, because in this case, there's a W squared on both sides. So either way, we're going to make a mess of getting rid of that. So I'm going to move it this way. So minus W squared minus 8W and minus 60. And once I do that, that crosses out everything because I did it on this side as well. So my W squares go away. I end up with 4W minus 40. Because 20 plus a negative 60 is 40. Now remember, every time you factor when the number in front is not 1, we want to look for a GCF. And in this case, 4 goes into both of those quite nicely. So I can factor out a 4 because 4 times W is 4W and 4 times a negative 10 is a negative 40. Because when you factor out, you're just putting it in a form that when I distribute it back through, I get back what I started with. And then W minus 10 equals 0. So our width of our original is going to be 10. The width of the original is 10, right? So original is going to be 10 width. So the original rectangle, before we started making all of our changes, the width equals 10. The length is our width plus 8, so the length is 18. Then when we added 2 to the width, the new one, so the new room with our new dimensions is going to be 12 because it's 10 plus 2. And then our new length is going to be 10 plus 10, so it's going to be 20. So the original is a 10 by 18 and the new is 12 by 20 to answer the question that they asked. That was after you got through all the factoring. Now, how that looks in your calculator again. So if we go up here, we got down to maybe, let's just go where we weren't even multiplying much. We just set up the equation. So it was going to be x plus 10 for the length times x plus 2 for the width was equal to, it was the area that it was, that's x, move my cursor, sorry, x times x plus 8. And then we're adding 60 to it as well. If we add 60 to it as well, maybe this isn't going to work. X plus 10, x plus 2 equals x plus 8, x plus 60. I'm actually kind of glad this doesn't work because that was going to be pretty wild if you were going to be able to get away with that. So x squared plus 8x plus 60. And now we see our positive 10 right here. And in this case, we end up with a linear function. That linear function, because we ended up with the 4x, because those x squareds take care of themselves and cross each other out. So your answer is 10. That's the only place it crosses the x-axis. And if you don't believe it, then scan way out. And you can see, once you get about this far out, you've already determined that you're in the right place. And that's our only answer. So again, it's where it crosses the x-axis. And that x value is 10. And then you just have to go back in and plug it back in. All right, that's Desmos for number 3. All right, and we're going to go ahead and do one more. We're going to do number 4. So the length of a rectangle lot is 4 rods greater. Now, I don't know what a rod is. Don't worry about that part, okay? Oops, sorry. The length of a rectangular lot is 4 rods. Just pretend like it's feet. That's fine. So a length of a rectangular lot is 4 greater than its width again. So width, and then the length is 4 greater. So width plus 4. Length equals width plus 4. The area is 60 square rods, so 60 feet squared. Find the dimensions of the lot. This one's even more basic than the ones before because now it's just length times width equals 60. So W plus 4 equals 60. And just for fun, to show you how easy this can be, as long as you can set these bad boys up, if I plug this in, so x, and we have to use x again because you're in Desmos and it doesn't know what you're talking about when you're doing your other variables, equals 60, it appears that we should have 2 answer choices of either a negative 10 and a positive 6. And I'm scanned way out. That's why those numbers look so bad. So positive 6 and negative 10 should be the answers that we get. So going back, let's see if we can get it right. So W times W is W squared. W times 4 is 4w equals 60. As soon as you see that x squared, know you have to get it equal to 0, or in this case, w squared, sorry. So I'm going to subtract 60, and that's going to give me w squared plus 4w minus 60 equals 0. I'm looking for the numbers I'll multiply together to get 60 that will add or subtract to give me 4. And our answers before we saw were, let's go look at it one more time. It looks like a negative 10 and a 6. A negative 10 and 6 were my answers. 10 times 6 does give me 60. We want a positive 4, so it's going to be a negative 6 in our factors. So x plus 10, x minus 6. Again, these are factors. When you're looking at your graph, you are finding the solutions, x-intercepts, or roots, and that's when we take our factors and do x plus 10 equals 0, move that 10, and x is going to become a negative 10. Then x minus 6 equals 0, move that 6, and x equals a positive 6. Lengths can never be negative, so you definitely want to pay attention to that x equals 6. And then from there, our width is going to be 6, and then our 6 plus 4, so our length is 10. So it's a 6 by 10 lot of the original. So 6 by 10. All right, guys, hopefully that's starting to make some sense. Be looking for some more in our upcoming videos. Have a great day, guys.